Okay, in this section, we're going to talk about graphing quadratic functions. We're in section 3.1, by the way. And this essentially means graphing parabolas. So that's what the section is about. Definition, a quadratic function is a function of the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. In this section, we're going to look at two methods for graphing a quadratic function. As a note, the domain of any quadratic function is all real numbers. Method 1 for graphing a quadratic is to use properties of a quadratic function. In method 1, we're going to check if the parabola opens up or down. We're going to know that immediately by knowing the a value, whether it's positive or negative. If it's positive, it opens up. If it's negative, it opens down. And then after we find that, we're going to find the vertex, v. The vertex is the highest or lowest point on the parabola. V is equal to negative b over 2a, and then f of negative b over 2a. After we find that, we're going to find all the intercepts, and then we're going to plot more points if it's necessary, and then sketch the graph. Okay, so problem 1, graph each quadratic function using the 4 steps given above, and I'll just show all of my work on the side here. Problem 1, f of x equal x squared plus 2x minus 3. Step 1 is to check if the parabola opens up or down. 1 times x squared is greater than 0. And so so because 1 is greater than 0, that means that the parabola is going to open up. Step 2, v is equal to negative b divided by 2a. Negative 2 divided by 2 times 1 is negative 1. Okay, f of negative 1 gives me 1 minus 2 minus 3 gives me negative 4. Negative 1, negative 4 is the vertex. Okay, negative 1, negative 4. Step 3 is to find the intercepts. So to find the x-intercepts, I got to let y be 0 and solve for x. X squared plus 2x minus 3 equals 0 factors nicely as x plus 3 times x minus 1 equals 0. And so x equals negative 3 and x equals 1. Create the two intercepts. To find the y-intercepts, I let y be 0, or I find f of 0, which is negative 3. Okay, so at 0 and negative 3, right there is the y-intercept. And I've got the two x-intercepts plotted there as well. Okay. Problem 2, f of x equals negative 3x squared plus 6x plus 1. A is negative 3, and that's less than 0, so the parabola opens down. Negative b over 2a, negative 6 divided by 2 times negative 3 is negative 6. Negative 6 over negative 6 is 1. F of 1 gives me negative 3 plus 6 is 3 plus 1 is 4. 1, 4 is the vertex. Okay, so there's 1, 4. To find the x-intercepts, I let y be 0. And to solve this equation here, I need to use the quadratic formula. X is equal to the opposite of b, plus or minus the square root of b squared minus 4ac. So 36 minus 4 times negative 3 times c. 36 plus 12 is 48, divided by negative 6. Okay, well, I can, root 48 breaks down nicely as 3 root 4, but I'd say why don't I go to the calculator and punch this in. Negative 6 plus or minus root 48 divided by negative 6, x is equal to negative 0.15, and x is approximately 2.15, are the two intercepts. To find the y-intercepts, I need to let y be 0 and solve for x. When y is 0, or when x is 0, excuse me, when x is 0, I get 1. Okay, so 0, 1 is on the graph. Here's negative 0.15, 0, and then 2.15, 0. Okay, all three of those intercepts are below the vertex, and that should always happen. That should always happen. Either be above or below the vertex, depending on if the parabola opens up or down. Step 3 is to use the four-step process again. So f of x equals 3x squared minus 3x plus 2. A is 3, and since that's a positive, I get a parabola that opens up. It should be up. And the vertex, negative b divided by 2a. 3 divided by 2 times 6 is 3/6. So 1/2. F of 1/2. 1/2 squared is 1/4. Times 3 is 3/4. Minus 3/2 plus 2. Negative 3/2 plus 2 is 1/2. So negative 3/4 plus 1/2 gives me, or 3/4 plus 1/2 gives me 5/4. And so, okay, 1/2, 5/4 is the vertex. The x-intercepts, negative b plus minus b squared of b squared minus 4ac all over 2a. 3 plus or minus the square root of b squared. Negative 3 squared is 9, minus 4 times a times c. 4 times 3 times 2 is 24. 9 minus 24 gives me negative 15. Divided by 2a, it's 6. Okay, so I get the square root of negative 15. And the square root of a negative is not a real number. So there's none where where I'm going to have any x-intercepts. I will always have a y-intercept though. Okay, so to find the y-intercept, I let x be 0 and solve for y. Y is 2. 0, 2 is on the graph. And if I go 1 unit or a half unit away from the vertex on the right, at 1, 3 minus 3 is 0, plus 2 is 2. So 1, 2 is on the graph. Okay, the intercepts will only be 1, which is at 0, 2. Okay, another method for graphing a quadratic is to use what we know about transformations. Sometimes a quadratic function is written in the form a times x minus h squared plus k, in which case we prefer to use transformations on y equal x squared. We will make 4 graphs when using this method to show each transformation, and then the 4th graph will represent the answer. So step 1 is to graph y equal x squared. Okay, that's when we're going to graph on every single one of these, y equal x squared. Step 2, graph y equal a times x squared by multiplying each y coordinate of x squared by a. Just as before, the value of a tells us if the parabola opens up or down. Okay. Step 3, graph y equals a times x minus h squared. For this graph, we're going to be shifting the graph of y equal a times x squared horizontally by h units. And then graph the original function. For this graph, we will be shifting the graph of the previous graph there, y equal a times x minus h squared, vertically by k units. The vertex is going to be at hk, the point. Okay, so the point, let's see, x minus negative 1, same as x plus 1, 2. So negative 1, 2, I can know right away that that's my vertex. Okay, and that looks good. So let's graph each function using transformations. Write the equation of the graph below the graph. So I've got f of x equals 3 times x plus 1 squared plus 2. Well, my first graph is y equal x squared. The second graph, y equal 3 times x squared. I'm going to multiply all the x values by 3, or the y values by 3. So 0, 0 is going to stay right at 0, 0. 1, 1 is going to be at 1, 3. Negative 1, 1 is going to be at negative 1, 3. 2, 4 is going to be at 2, 12. And negative 2, 4 is going to be at negative 2, 12. Both those points are off the scale, of course. So I'll just stick with these 3 labeled points for the rest of the way here. The next graph is going to be taking the original graph, but then shifting to the left 1 unit. Y equals 3 times x plus 1 squared. Means that I'm going to shift this graph to the left 1. And so when I shift this graph to the left 1, I will it'll be at negative 1, 0, and then 0, 3, and then negative 2, 3. The graph is going to stay the same. Notice how this graph has been vertically stretched by a factor of 3. Okay. And then the last graph is our original function there. Y equals 3 times x plus 1 squared plus 2 means that I've got y equals, let's see here. I need to shift the previous graph up 2 units. So, because of the plus 2. So negative 1, 0 is going to be at negative 1, 2. 0, 3 is going to be at 0, 5. And negative 2, 3 is going to be at negative 2, 5. Okay, and so I draw the graph of the function. Okay, why don't we stop right there?